Hello everyone and welcome back to my channel Wisdom. In today's video, I will be teaching you the chapter on tides, Standard 7, Geography. Now observe these two pictures given on the slide, figure 3.1a and figure 3.1b. Both these pictures are there in the textbook. Now notice the difference between these pictures. And let us look at the upcoming answers, question and answers. Question 1. Do the above photographs show the same place or different places? Answer. Both the photographs show the same place. Question 2. Observe and note the spread of water seen in both the photographs. Answer. The level of water is higher in the first picture and lower in the second. Question 3. What is this natural event called? Answer. This natural event is called tide. Now again, as we look at these two pictures, we notice that in the first picture, the sea water is sometimes very close to the sea coast, and in the second, the sea water is far away from the coast. These movements of the sea water is called tides. Now, mostly all the coasts that is on the earth experience tides. When the sea water is much near the coast, it is said to be a high tide. And when the sea water is away from the coast, it is said to be a low tide. Now, as we know that all the coasts on the earth experience tides, these occurrences of the tides are a natural phenomena, and we experience both high tide as well as low tide daily and regularly. Now this happens because the level of sea water changes after a specific period of time. So, after every 12 hours and 25 minutes, a cycle of high tide and low tide gets completed. So, if you look at the given picture, in a day we experience two high tides and two low tides alternatively in a single day. How does this happen? This is because the tides are directly related to the sun, the moon, and the earth, and also the presence of the gravitational and centrifugal forces of the earth that interacts between them. Now, if we keep a small stone or a piece of chalk on a notebook and we move or tilt the notebook from the left side to the right, in which direction would the piece of chalk fall? Yes, it is obvious that the chalk will fall to the right side. Now, if a mixer jar is filled with water and we switch on the mixer, what will happen to the water in the mixer? The water in the mixer will swirl around, forming a bulge at the sides and a depression at the center, just as it is shown in the picture. Again, if we take a half glass of water and we slowly move the glass in one direction, that is in a circular motion, Where did the water in the glass show a bulge? We see a bulge at the sides of the glass. Suppose we whirl a key ring around a finger. What effect will the movement have on the things attached to the key rings? The things attached to the key ring will move around and away from the center. Now, which forces could be operating in the above discussed activities? In the first chalk and notebook activity, we have the Earth's gravitational force that is working. In the activities of the mixer, a glass of water, and a key ring, we have the Earth's centrifugal force that is working. In all of the following activities, which force is greater, the centrifugal or the gravitational? The centrifugal force was greater than the gravitational force. The centrifugal force acts in the direction opposite to the gravitational force. Centrifugal means going away from the center. We can experience this force when we sit in the giant wheel. Once it starts, we notice that as the seats are spinning, it leans outward away from the wheel. This happens due to the effect of the centrifugal force. Now let us understand how the centrifugal and gravitational forces work together on the Earth. Due to its rotation, the Earth gets a type of power or force. This force works away from the center. It is called the centrifugal force. Now, had this force only been in operation on the Earth, any object would be easily thrown out into space. But thanks to the gravitational force that is working at the same time, the gravitational force on the Earth is many times greater than the Earth's centrifugal force. That is why any object on the surface of the Earth remains at the place where it exists. These are the following factors that are responsible for the occurrence of tides. The first one, the gravitational pull of the moon and the sun as well as that of the earth. The second, the revolution of the earth around the sun and the indirect revolution of the moon around the sun. And the third, the centrifugal force generated due to the rotation of the earth. Now let us understand how tides occur. Considering the distance of the moon and the sun from that of the earth, the moon is much closer to the earth. This is the reason the moon's gravitational force becomes more effective than that of the sun. A place on the earth experiencing high or low tide will also experience a high or low tide respectively and at the same time. That is, if the north is experiencing a low tide, then the south will also experience a low tide. If the east is experiencing a high tide, then the west will also experience a high tide. This happens due to the centrifugal force of the earth. Let us understand this better by looking at this diagram. The earth is divided into meridians. Suppose there is a high tide at 0° meridian, then the meridian at 180° will also experience a high tide. The meridians that are at right angles to those having high tide will experience low tide at the same time. Now answer this question. If it is a high tide at 0° and 180° meridians, then at which meridians will low tide occur? Answer: the low tide will occur at 90° west and 90° east. Just as the timing of the tides vary every day, the range of a tide also keeps on changing. The highest high tide occurs on full moon and new moon days, and at the first and third quarter days, the high tide is at its minimum. There are two types of tides. One is a spring tide. This type of a tide occurs only on a new moon and full moon day. This is because the position of the earth, the moon, and the sun lie in the same plane. Therefore, the gravitational pull of the sun and the moon act in the same direction. And due to this, the total pull increases. That is why the high tide on these days is much higher than the average high tide. This is known as the spring tide. Now, as the bulge at the high tide is greater, the water at the low tide recedes and becomes much more. So the water level during the spring tide is higher than the average high tides and lower than the average low tides. The other type of tide is the neap tide. Here, the position of the moon is in a right angle with respect to the earth and the sun. This position occurs twice a month, that is, on the first and third quarter of each month. So here, the forces of both the sun and the moon operate at right angles on the earth. At the places where the sun causes a high tide, there the gravitational pull of the moon, which is at right angles, also act on the sea water. So here the water level rise is less than usual at the time of high tide. Similarly, the fall in water level is seen less than usual at the same time of low tide. This happens because the attraction of the sun and the moon are not complementary but at right angles to each other. Such tides are called neap tides. Neap tides are a little lower than the average high tides and a little higher than the average low tides. Now let us do a small recap of what we learned in today's video. Today, we have learnt about tides. When the water at the coast is near, we say that it is a high tide. When the water at the coast is far away, we say that it is a low tide. Tides occur due to the gravitational force, the centrifugal force of the earth, and the revolution of the earth. And there are two types of tides, that is the spring tide and the neap tide. In the next video, I shall continue with the remaining part of the lesson. This was all for now. Thank you and have a nice day.